In this video, we're going to start to take a look at linear equations, and we're going to dive a little bit deeper in the next few sections in Chapter 1. So linear equations look like ax plus by equals c, where c can be any number, fractions, decimals, whole numbers, negative numbers, anything like that. So a lot of times it looks like 2x minus 5y equals 8, like that. Or it could be, or this could be all rearranged. You could have y equals 3x minus 4. Okay, I still have an x term, a y term, and a number term. You could also be missing any one of these. So you could have like 2x equals 4 is also a linear equation. Or you could have 2x plus 3 equals 7 is also a linear equation. Okay, so basically for a linear equation, you're looking for an x and or a y with no exponents and numbers. Okay, that's what a linear equation looks like. So the first thing we want to do is we want to decide what the solutions look like and how to determine a solution. So let's say we want to know, is 2, 3 a solution to 3x minus 2y equals 4. Okay, so we want to know if this point is a solution to this line. So remember that points are given to you as x, y. Let's make that a little bit more readable. X, y. Okay, so the x is 2, the y is 3. If we want to know if this is a solution, we plug it in and we see if it's true. So true means that the two sides match. So whatever the two sides are, they're going to match. 0 equals 0, negative 5 equals negative 5. Something like that. So let's go ahead and plug this in. So we're going to plug in 2 for 3. I'm sorry, we're going to plug in 2 for x. So it's going to be 3 times 2. So we're going to plug in 2 here. And we're going to plug in 3 here. That's a lot of 2's and 3's. Okay, so we plugged in 2 for x, and we plugged in 3 for y. And we want to know, is that equal to 4? Okay, so I've got 3 times 2 is 6. 2 times 3 is 6. Is that equal to 4? That would be 0. And that is not equal to 4, so that's not a solution. Okay, that also means it's not a point on the line. Okay, so a solution here means that it's also a point on this line that we're gonna see later when we talk about it. Okay, so let's say we want to do the same thing, but we want to know, is 2, 1 a solution? And we'll use the same line. 3x minus 2y equals 4. So let's try this one. So we would put in, again, we put in 2 for x, 1 for y. So we put in 2 for x, and we put in 1 for y, and we want to know if that's equal to 4. So I'm going to have 6 minus 2. Is that equal to 4? Yes, it definitely is. We would have 4 equals 4. So anytime you get a true statement like this where the two sides match, okay, so 4 equals 4, 0 equals 0, negative 2 equals negative 2, that would be yes, it is a solution. So that means that 2, 1 is a point on this line. Okay, so we know what linear equations look like. We know how to decide if we have a solution to linear equations. The next thing that we want to do is we're going to look at the intercept method to graph them. Okay, so a linear equation is going to make a line. That's why we call it linear. So looking at intercepts, we have intercepts for any type of graph. We can have intercepts for any type of graph, not just lines. So it can be any type of graph like this. Intercepts mean it's where they cross the x and y axis. So if it crosses the x-axis, it's an x-intercept. And if it crosses the y-axis, it's a y-intercept. Okay, so if it crosses the x-axis, it's an x-intercept. If it crosses the y-axis, it's a y-intercept. X-intercepts will always be in the form of some number and then 0. Okay, if you're on the x-axis, you always have to have some number and then 0. Because remember, the first number tells you to move left or right. The second number tells you to move up or down. But we're not going to move up or down. We're going to stay on the x-axis. So you could have, so x-intercepts might be something like negative 2, 0. or 3, 0, or 5, 0. Those are all x-intercepts, and I know just by looking at them because y equals 0. So if you want to have an x-intercept, you have to have y equal to 0. All right, y-intercepts, same kind of idea. If I'm on the y-axis, then I don't move left or right. I only move up or down. So that means that my first coordinate is going to be 0. Let's see if I can fit it in here by the point. My first coordinate is going to be 0, and my second coordinate is going to be some sort of number. Okay, so I don't move left or right, I just move up or down. So it could be like 0, 2, we move up 2. It could be 0, -4, that would be moved down 4. It could be 0, 5. Okay, so y-intercepts are always in this form, 0 and then a number. So what that means to have a y-intercept is that x has to be equal to 0. All right, and that's true. We're talking about lines right now, but that's true for any function out there. If you want to find the x-intercept, you look at y equals 0, and if you want to find the y-intercept, you look at x equals 0. All right, so if we want to graph a line using the intercepts, So let's say we want to graph 2x minus 5y equals 20 using intercepts. Okay, so we know that this is a linear equation. We've got an x, a y, no exponents, some numbers thrown in, that's fine. This is going to be a linear equation, which means it's going to make a line. If I can find the 2 intercepts, then I can graph that line because 2 points make a line. So we're going to use what we just did over here to do that. So I'm going to use, to find the x-intercept, I'm going to use y equals 0. So I get 2x minus 5 times 0 equals 20. So when I plug in 0, that whole term's going to disappear because it's going to become 0. Anything times 0 is 0. So I get 2x equals 20. I want to get x by itself, so I do the opposite. I divide by 2. And I get the x is equal to 10. And then I do the same thing for the y-intercept, or similar. For the y-intercept, I use x equals 0. So I'm going to have 2 times 0 minus 5 times y equals 20. So up here I put 0 in for x, and I want to know what y that gives me. So again, 2 times 0 is 0, that's gone. So I have negative 5y equals 20. Don't lose that negative. And I want to do the opposite. So it's negative 5 times y, so the opposite would be divide. And when I divide by negative 5, I'm going to get 4, and it's going to be negative, because positive, negative would come out negative. Okay, so I know the intercepts for this graph are at 10 on the x-axis and negative 4 on the y-axis. So when I go to graph it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I just did a 10 by 10 grid here. So I'm going to go to x equals 10. That's positive 10. 2, 4, 6, 8, 10. That's right there. So I have an x-intercept here, and I have a y-intercept at negative 4. Okay, so there's the x-axis, there's the y-axis. So y-intercept at negative 4. So if I have an x-intercept at 10 and a y-intercept at negative 4, then my line has to pass through those 2 points. Okay, and sometimes that's easier to do than the methods that we're going to talk about in the next few sections. Okay, so you've probably learned other ways to graph lines. Don't forget the intercept method, because to get this equation in a different form, to do it a different way, it could get pretty messy. But this is pretty easy. You just plug in 0, solve for the other one, plug in 0, solve for the other one. Even if you get fractions, it's only going to be in the last step. So that's not terrible, okay? So that's how we graph using intercepts. All right, so the last thing that we want to do is talk about horizontal and vertical lines. So horizontal and vertical lines are kind of like a special case where you only have X or you only have Y. And you kind of have to know that in the context that's equation of a line, not just a value, because it can look the same. So let's say that I have X equals 4. All right, maybe it says graph X equals 4. So I know this isn't just a value, this is an equation. So what that means is for this equation, the solutions all have X equals 4. And you say, well, I don't have any Y values. That means that Y can be anything. Okay, so your solutions would look like 4, 0, 4, 1, 4, 2, could be 4, -5. Y can be anything. Okay, so if you get horizontal and vertical backwards, remember this definition. X is 4, Y can be anything. So what happens if I graph those points? 1, 2, 3, 4. I get 4, 0. I get 4, 1. I get 4, 2. I get 4, -5. Okay, I could keep going, but now you should be able to see if X is always 4, I'm going to end up with a vertical line. Whoops, vertical line. Okay, so if you have X equals a number, it's going to be a vertical line at that point. So if you have X equals -2, you don't have to plot the points. That's just to help you think about it if you forget that it's a vertical line. You say, okay, that's a vertical line through, whoops, not a dash, through -2. Okay, so this one's at -2, this one's at +4. All right, so X equals a number gives you a vertical line. All right, so if you've got that, then the other one's got to be the horizontal line. So let's say we want to graph Y equals 3. So that means that Y is always 3, and X can be anything. So we have points like -2, 3, or 1, 3, or 0, 3, or 5, 3. Okay, those are all solutions to this equation because there's nowhere to plug in the X, so it can be anything. But Y has to be 3. 3 equals 3, 3 equals 3, 3 equals 3. So let's look at what that looks like. Okay, so I've got -2, +3, 1, 3, 0, 3, 5, 3. Okay, you see how that works? That makes a horizontal line. Okay, so if you have Y equals a number, that's always going to give you a horizontal line. So we don't have to plot the points. That's just to help you keep the difference between horizontal and vertical. Don't get them backwards. Let's say we want to graph Y equals -4. So it's going to be a horizontal line through -4. So we can just go ahead and graph that. We would go 1, 2, 3, 4. There's -4. And we would graph a horizontal line through that. Whoops, I missed it, didn't I? Let's try again. Okay. Okay, so X equals a number is vertical, and Y equals a number is horizontal. Okay, but if you ever forget, just think of it this way, and that might help you.